Right. Good afternoon, students. My name is Mr. Chimanda. Welcome back to another lesson on Wednesday. When this week we are talking about functions. So we've been speaking about functions from Monday and Tuesday. We now know how to find what is a function, what is a domain, what is a range. Yesterday we did linear functions, and we also did inverses of the functions. And we also stipulated what constitutes a function for it to be called a function. If it's an expression or a graph, how do we test? We did the vertical line test, and we also did the what's the name? Finding the inverse by interchanging and making y subject of the formula. We also did notations. So today we continue with quadratic functions. So we want to know, how do we find what is a quadratic function? What is its domain? What is its range? So that is what we are going to be doing today. So let's get down and let's do some concepts and examples so that we can get to know. So I'm going to quickly switch my cameras back to my working desk. So quadratic functions. So if we talk about quadratic functions, we're talking about functions that are in the form y is equal to ax squared. We're talking about functions that are in the form y is equal to ax squared, or they can be written as f of x is equal to ax squared, where a is just a constant, where a is just a constant. So now, before we dive into the quadratic functions, remember yesterday we spoke about inverse functions. Inverse functions. So, and remember our mappings. Our mappings, we have a 1 to 1, and we have a many to 1. Then we have a 1 to many, and we have a many to many. So we have a 1 to 1 and a many to 1, right? And a 1 to many, and we said only these two, and only these two they constitute functions, right? Because they only give one unique of output. So we say those two are only called functions, right? But now remember, it's going the 1 to 1. But now when you are going in, so this one is not a function, right? This one is not a function, and this one as well is not a function. So now, the inverse of a function does not necessarily mean that the inverse also itself is a function. So it means that if a 1 to many is a function, but now when I find the inverse does not become a function because it's now a 1 to many, because the inverse now will become a 1 to many, which is not a function. Which is not a function, right? So it means that in this case, the only function, the inverse that can constitute a function is an inverse of a 1 to 1. So that is a common, that is a function, comes from a mapping that is a 1 to 1 function. So now we can write it nicely that the inverse of a function that can be classified, I'm just writing in my own language, that can be classified as a function as well. is follows a one-to-one mapping. All other mappings, the inverse is not a function, but only when it's a one-to-one, then when we're replacing, it also becomes a one-to-one. That is the only function or type of mapping that can give us an inverse that we can also call a function. You shall see later on when we're doing the vertical line test on quadratic functions. You shall later realize that sometimes we can get it to be a function, or we can manipulate it so that it becomes a what? It becomes a function. So let's get back to quadratic functions. So I'm going to write quadratic functions on this side. So a quadratic function is, do you know how to draw the graph of a quadratic function? So if I have y is equal to x squared, I can draw, these are hyperbolas, the parabola. We all know how to draw a parabola. A parabola is written like this. And if I have y is equal to 2x squared, it just means the parabola is just narrower. It's just narrower than this one. It means it's just a little bit narrower than this one. So we have, so it means if this increases, my becomes narrower and narrower and narrower. Right. So if I have this, is it a function? That's the first thing that I want to know. Is it a function? What I do the vertical line test. Does the vertical line cross once everywhere? Yes. It crosses once. Yeah. Does it also cross once? Yes. It crosses once. Then, wonderful. It is a what? It is a function. It is a function. Right. Now, if it is a function, then now I want to find its inverse. So it means if I'm just given any y is equals to 4x squared or y is equals to 5x squared, I can draw my parabola nicely and I can conclude that it is a function. I have no problem with that. Now, how do we find its inverse? So finding the inverse, we just follow the same step. Step number one, I'll write it as number one, y is equal to x squared. I'm going to find the inverse of this one. Step number two, I interchange. Now I'll write x is equal to y squared, which I cannot. Okay, the writing on the left. Okay, I am going to adjust. I always try to move my paper because the paper is a little bit lengthy. So I always try to move it. So I always come back and refocus here so that you can see. So I'll always be shifting my paper so that you will be able to see. So sometimes when I'm done with this section, you must be able to write when I'm writing. I don't know if you can see properly. Then when I'm moving, I go this side. So, okay, let me just try to adjust. Just give me a minute. And it's blue. I'm going to try to use a bigger pen, which is x is equal to y squared. I don't know if it is still blurry. Right. So now I make y the subject of the formula. So if I make y the subject of the formula here, I will get y is equal to the plus or minus square root of x. Remember, when you square root, you get plus or minus. So you get plus or minus square root of what? Square root of x. So I can now write in the notation, which is equal to plus or minus the square root of x. Now, so how do I know how to draw the graph of plus or minus the square root of x? So I'm going to draw it here. So the graph of plus or minus, so it is a parabola like this. But it is, so this is the graph of y is equal to plus or minus the square root of x. So if this of y is equal to plus or minus the square root of x, what do I mean? This side is the positive side. So this is y is equal to the square root of x. And this side is y is equal to negative square root of x if I decide to split them. But I can just write the whole function as y is equal to plus or minus the square root of what? The square root of x. Now, so if this is the graph, and now I want to draw it on the same axis, because remember, with functions, they'll always ask you to draw on the same what? On the same axis. So we must be able to draw this one and this one on the same axis, and to see does it give a reflection of one another. So that's what we want to find out. So now I now know my graph of y is equal to x squared. Now I now know my graph. Drawing graphs it's not difficult. If you don't know how to draw graphs, you can plot your points on your calculator, or you can draw a table. Do you remember these tables where you put your x and your y, then you put your values, then you can plot your graph nicely. So drawing a graph should not be very difficult. Y is the graph in the first and third quadrant. Y is the graph. Okay, this is the graph of the y is equal to plus or minus the square root of x. That is how the graph is drawn. So that is the only answer I can give you, because that is how the graph is drawn. Right. Now, I am going now to draw now on the same axis. So now I'm going to draw on the same axis. So we have, this is the y-axis and this is the x-axis. So now we draw it on the same. So this one, remember, it's y. It's y is equal to x squared. And the other one I'm going to draw with this one. This is y is equal to plus or minus the square root of x. Then I can neatly draw my y. Remember, it's a function, and its inverse, it's a reflection about the line y is equal to x. So if you can see that this line, and let's start from here. If I close this side, if I close this side, right, we can actually see that this one is a reflection of this one. And if I decide to close this side, this one, this part, this becomes, sorry, this side is a reflection of this side. Yes, the line y is equals to x is the line of symmetry. That's why it's called it. Because a reflection, it means this side is equal to this side. Right. So now, this is a reflection of this, and this one is also a reflection of this. They are all reflected about the line y is equals to x. So even if we have y is equals to 2x squared, we can still reflect. This is how a parabola looks, right? So now, the question that some of you are asking is, how do we know that the graph is reflected up and not down? How do we know that the graph is reflected up and not down? I don't know, I'm not understanding the question, but the graph is reflected not up or down, but it is reflected about the line y is equal to x. That's how the graph is reflected when it is an inverse. Because the reflections can be reflected about any line. We can reflect about the x-axis, we can reflect about the y-axis, but if we are talking about inverse functions, it means we are talking about a reflection about the line y is equal to x. Right. So now let's do some more example, another example. Now, so what happens now is that if we look carefully, I'm going to come back here. I am going to come back here. If I come back here, now, if you notice up here, we did a vertical line test. When we did our vertical line test, we noticed that y is equals to x squared is a function. Because when you draw the vertical line, it only passes through the curve once at any point on the line. At all the points on that curve, it must pass once. But if we get back here, right, on this one, if I draw a vertical line, it passes through how many points? It passes through 2 points. So if it passes through 2 points, it means that it is not a function. So though the function, original function, satisfies all the conditions of being a function, this one, which is the inverse, does not satisfy. So it means the inverse of a parabola or the inverse of a quadratic expression is not a function itself. Right? But what can we do? We can manipulate it so that it becomes a function. Right? It becomes a what? A function. Because what are we saying? This is what we are saying for OX and we are saying for OY. So I'm going to show you now what conditions do we set so that it becomes a what? It becomes a function. Let me quickly take this away. So now we're still on quadratic. I'm just going to bring it down a little bit. We're still on quadratic functions. Right? That is just a shortcut way of writing functions. Now, so I am going to draw. I'll use a ruler so that it becomes neater. So we have x, we have y, and x-axis. Then we can now draw our parabola, which is this one. The other one, I will draw it using this one. So before I draw the other one, we can now see that, okay, this one, it's a It's for all x because x is stretching from negative infinity to positive infinity. And here it's 0. That's correct. Right? Now, if from negative infinity to positive infinity. Now we have this one. So this is y is equal to x squared. Then we have another one, which is the inverse. It passes through the same. This is y is equal to negative plus or minus square root of x, of which I said the top part is the positive, is y is equals to plus positive square root of x, and the bottom part is y is equals to negative x. And you can actually see that this arm is a reflection of this arm, and this arm is a reflection of this arm. Now I am going to draw my symmetry line, which is my line of reflection. Now, yes, we need to stay positive. No one is going to fail. I'm just reading the comments now. So when we look at this now, we said this one is a function because it satisfies. Right? This one is a what? Is a function. And this one is not a function because if I draw a line, it cuts through these 2 points. But if I can omit these 2 quadrants, it means I am saying if I can say the domain, my domain of this one, of y is equal to x. So y is equal to x squared. And my domain, I say x is greater than 0. Greater or equal to 0. So I'm starting from here. Greater or equal to what? To 0. It means I am talking about this arm only. From there to there. I'm not talking about this one. I am talking about this. So I've adjusted my domain, which is x, which is x is greater than or equal to 0. So I am only talking about this part, right? I am going to draw that part quickly. So I am only talking about this part. And here I also have this part. So this is y is equal to x squared, but only when x is greater or equal to 0 for this one. Right? For this one. And the inverse now, if you can check, is y is equal to the square root of x, which is the positive part, because I've taken the positive part. And I have my line y is equal to x. So if what I'm basically saying is that, if we have the line y is equal to x, and we are given a condition that this parabola, we're only interested in x is greater or equal to 0, right? I'm only interested in from this part, where I'm not interested in this part. So it means I also get a reflection on this part. So if I draw my vertical line test, it passes through 1. And if I draw my vertical line test on the original function, it passes through 1 point. So my original function is still a function. And my inverse is now also a function. Why? Because it is only cutting once. This part only reflects on this part. So it means it's 1. So what I'm saying is, if we have this function, and if I give it a domain, a conditional domain, the inverse now will also be a function. If I had said x is an element of real numbers, then the inverse would not be would not be a function. Why? Because it will be going also through here. But only the condition now, right? Only the condition. Okay, I will repeat this again. We have a parabola, which is y is equal to x squared. And this one is x is an element of real numbers. It means x, I can take x from any point from negative infinity to positive infinity. Then I can draw my graph, right? Then the reflection is this turned parabola, which is y is equals to plus or minus negative root of x. So, and it reflects about the line y is equal to x, right? So, if you check now, this is coming from this point up to that point, and this one is coming from this point to that point. But if I decide to say, okay, I only want my x to start at 0 for the original function, I only want that's why I'm saying x is greater or equal to 0. Right? That's why I am saying x is greater or equal to 0. Because with this one, y is equal to x squared, and x is an element of real numbers. It's starting from negative infinity to positive. So it means my graph can go up there and my graph can go up there. Right. Now, with this one, I've decided to say, okay, I don't want this part anymore. I'm only interested in this part. That's why I said x is greater or equal to 0. So I've rechanged my domain from x is equal as an element of real numbers to x is greater or equal to 0. That's what I've just done. The graph is still the same. So I don't have to draw any from here because I'm only interested from 0 and up to infinity. I'm not interested in anything behind. I don't know how if you have understood that, right? For my original function, which is this one, I'm only interested. I've restricted my domain to x is greater than 0. This one, the domain is x is an element of real numbers, starting from negative infinity to positive infinity. But with this one, I said, no, I only want to start drawing my line from 0 and upwards. So I only have one arm. So the reflection of this one is this line, which is y is equals to the square root of x. But if I draw a vertical line to check if it's a function, it cuts this line, this curve once. So y is equals to x squared when x is greater than 0 is a function. This is a function. If I also draw a line, just concentrating on this curve, it cuts once, it becomes a function as well. So in basic essence, we are saying that if I restrict my domain to x is greater than 0, the inverse that I get will also become a function because it passes the vertical line test. All right. Now, I am now going to do the bottom part. Right. If I restrict, so I'm also going to draw something like this. So if I draw this side, let me draw with this pen. If I only draw this arm, this is y is equal to x squared, but x is less than or equal to 0. Remember when I drew this side, it was y is equals to x squared and x is greater than 0. Here it is y is equal to x squared and x is less than or equal to 0 because this is only up. If I draw this side, it's y is equals to x squared, right? So now, if I draw this side, and remember, I always have my line y is equal to x. And the reflection of this one is this one. And this is y is equal to minus square root of x. So now, this one is a reflection of this one. So if what you see now, if I draw a vertical line, on the original function, it still remains a function because it cuts the vertical line test, passes only once. If I also draw a line on this one, on the inverse, it also cuts this graph once. So it becomes also a function. So on the original, let's look at the original. The graph is a function, but the inverse is not a function because it cuts 2 points. But when I restricted and said, okay, I only want my x to be, when I restricted my domain, my x is greater than 0, I only took the part here, and the inverse is also only this part, it becomes a function. If I also restrict here and say x is less than 0, I've restricted my domain from x is an element of real numbers to x is less than 0, then this remains a function, and the inverse also becomes a function. That is what I'm trying to imply, that you can get, if you restrict your domain, or if you are able to get the inverse as you are able to get the inverse also as a function. But in this case, the inverse is not a function. Here it's not a function. But here it is a function. And here it is a function. Just because we have restricted our domain. So I'm just going to quickly read some questions here, right? Say, how is an inverse of a parabola a function? That's what I was explaining here, that the inverse of a parabola is not a function. But if we restrict the domain to x is greater than 0, it becomes a function because it can pass the vertical line test. If we also restrict here, it becomes a function. But if our domain is x is an element of real numbers, then it is not a function. How do we know if x is greater or less than 0, say? Right. It's not like how do we know? We are seeing that, okay, if I the moment I try to, let's say x is greater than -1, I will have a piece here somehow. I'll have a piece. If I start at -1 here, I'll have a small piece here, of which if I draw now my line, it passes through 2 points. So I do not want that. That's why I'm saying we can only now see that if x is greater than 0. Are you only restricting the domain of the original graph, not the domain of the inverse? Yes, I'm only restricting the domain of the original graph, not the inverse. The reason why I want my inverse to be a function, so I'm only restricting the domain of the original graph. If I restrict it, I can actually see that, okay, here it creates a reflection about the line y is equals to x. So if I draw here one line and one line, it cuts at 1 point. Okay, the graph is restricted to take one root of an arm at a time. Yes, we only restrict the domain and leave the range as it is. Okay, as I think some of you. So say if the domain is restricted, the inverse becomes a one-to-one mapping. Thank you very much. It becomes a one-to-one mapping if it is restricted. So for a parabola, normally that's where we restrict it to x is less than 0 or x is greater than 0. Because this is for a simple parabola. You shall see that when we get other quadratic functions that are not as simple as this, because this is just a simple quadratic function. We shall get quadratic functions that are x is equal to x squared plus 4x plus 3. This is also a quadratic function, which does not follow this as exactly as the way where this one passes through the origin. This one passes through another point, depending on what we find here. We must find the maximum and the minimum. That's not a problem, because the maximum is, the minimum is this one. We also have a maximum when it's -x. So I think you have quite understood what when we are drawing the parabola and the graph of y is equal to plus or minus negative, plus or minus root of x. So when it is like this, I'll repeat, it is not, the inverse is not a function. But when we restrict, the inverse becomes a function. That is when we restrict. And if we restrict here again, the inverse also becomes a what? Becomes a function. So now, let's check out some questions on the textbooks that I've always been using. Let me quickly get it. Okay, here's the textbook. Right. I think I can explain using here now. You can actually see that, okay, we have a parabola, and this is the inverse, right? But the inverse does not normally follow, it's not a function, right? But we can restrict here. If we restrict, then this becomes a what? A function as well, because it passes the vertical line test. And here, if we draw again the vertical line, it also passes. So now we go to this now. The function, right? So let's go to this concept, which is the function in its inverse. Right? I will stop sharing now. Now, so we have a function and its inverse. So, and we have a domain and a range. And we have a domain and a range. Now, so if you shall, we shall prove it just now. The function, the domain of the function becomes the range of the inverse. And the range of the inverse becomes the domain of this function. Let's get back to what we were doing just now. Right? We are getting back to what we were doing just now so that we are able to prove this. Right? So if you notice, let's come here. We said this is the domain. X is less than 0. That's the domain. It becomes the range. So the range of this, the range of the inverse, you can actually see that here, y, the range is y. So my y is my graph in the positive, x is in the positive side of y or in the negative side. But this is the negative side and this is the positive side. So we can see the highest value that this curve can get is 0. Otherwise, everything else is less than 0. It's in this side. It's less than 0. So y is less than or equal to 0. That's what we mean by saying the domain becomes the range, right? Because here we're saying y is equals to x squared, and x is less than or equal to 0, right? But what is my range for the? My range now is also y is less than or equal, because why? I can see that the highest point I'm getting here is 0 for y. Nothing goes up. Everything starts going down. So y is less than 0. That's why I'm saying my domain becomes my range. Right? And my range becomes my domain. I can explain it using this part. Right? If this part, look at this curve, the minimum point it can get is 0. Everything else is above. So we will say it's what? The domain y, x. So the range here, which is what? What is our range? It's y is greater than what? That is 0. Which is our domain this side. So they interchange. Say is the range, say is it the range for the inverse or the graph? If we come back here, the domain of the function becomes the range of the inverse. Or the range of the inverse becomes the domain of the function. So it's just vice versa. Right? It's just vice versa. But our main emphasis was just to explain that a quadratic function is not a quadratic function. If we find the inverse, it is not a function. But if we restrict our domain, normally if we restrict our domain about the symmetry line, because remember a parabola has got a line of what? Has a line of symmetry. So if we restrict about the line of symmetry, we shall see when we are doing maximum points and minimum points, so that we know, because we would want to know, why did we choose 0? Why did we choose 0, right? What if our parabola is passing through, what if our parabola is passing through this point? What if it is passing through this point? How do I get to know how to restrict my what? How to restrict my domain? What value should I put here? That comes in if we know how to find the maximum and the minimum point, which is tomorrow's lesson. Tomorrow we will now be trying to find how do we restrict our domain so that our inverse becomes a function. Right. So thank you very much for today. Thank you for being interactive. Thank you for asking questions where you do not understand. Always and ask. It's good to ask and be interactive. That's how you are able to grasp the concept. So thank you very much. Tomorrow we continue. Try to go through the lesson again. You'll find it on our YouTube channel, and try to listen to what I was explaining and how do we restrict. So this one we're restricting because it is just a simple quadratic expression. But when we get to expressions that are not as simple, we would want to find out how do we restrict our domain so that our inverse becomes a function. So thank you very much. Enjoy your day.